Hi there, what I want to do now is talk about the kidney. So, where are they? They are just below your rib cage on either side of your spine, and they have two functions: the reabsorption of useful products and the filtration. So it filters your blood like a sieve, leaving the big stuff behind. Only little stuff like urea and salts and glucose and water gets to go into your kidney. And as that moves through your kidney, the body sort of decides what it's going to reabsorb. It kind of says, well, I need that glucose, I need those salts, I need that water, and it reabsorbs what it needs to reabsorb. You've got this light brown cortex on the outside, a darker brown medulla on the inside, and then you've got this fibrous calyx, this collecting ducts here. The calyx is where the finished product, urine, is collected and passed to the ureter and then the bladder. So here we are. Urine is produced by these microscopic structures in the kidney. They're called nephrons. So we've got this diagram here on the right, that blue tube there. That's a kidney nephron, and it's made up of different tubules. Okay, but the beginning part is the glomerulus, this sort of spherical structure here, the glomerulus. Let's have a little look at in more detail at what the glomerulus does. The glomerulus is the sieve. So what happens is, you've got blood coming in through the afferent arteriole. This is blood coming into the kidney. It goes into these blood capillaries, and the small stuff can squeeze out because the pressure is really, really high. So small stuff like ions and water and glucose and urea, the waste product, they squeeze out, they form this thing called the filtrate, and the filtrate moves off through the proximal convoluted tubule. The big stuff like proteins cannot get through. If you've got protein in your urine, then you have some sort of kidney damage. It simply shouldn't be the case. And there is a test for protein in the urine. Here's what it looks like. This has obviously been stained, this kind of purple stain, and you can make out the individual red blood cells here. And you can also make out this sort of semicircle or almost full circle, which is the Bowman's capsule, this white circle. So you can start to make out these structures on a diagram like this, on this microscope image. So first of all, after the Bowman's capsule, after the filtration happens and we're left with this liquid, we are in the proximal convoluted tubule. Proximal convoluted tubule, we get active transport happening. The active transport of sodium and potassium salts into the surroundings. What's going to happen then is the water is going to follow by osmosis. Remember osmosis, the movement of water from a dilute to a less dilute. If you're not very comfortable talking about active transport and osmosis and diffusion, then have a click on this little link here and you can watch my video on it. So we begin the process of reabsorbing salts and water into our body at the proximal convoluted tubule. Then we dive down into the medulla with this thing called the loop of Henle. Now, the ascending limb, the bit going back up, that bit is permeable only to ions, and once again we get the active transport of sodium, potassium, chlorine pumping out by active transport. Now this takes ATP. This is an energetic process. It uses a lot of energy, and what this does is it makes the medulla really salty or hypertonic. The descending limb is permeable to water and only water. And water, again by osmosis, will move out, because the surroundings are hypertonic, the water will move out of the descending limb, and that water will get reabsorbed by blood capillaries, which are not shown. So there are blood capillaries surrounding this loop of Henle. So the loop of Henle is long enough to allow lots of water to be reabsorbed back into the body. If it was really short, you wouldn't get much of a chance to reabsorb water back into the body. This creature here, the kangaroo rat, has a really long loop of Henle in its kidney. Now what this does is it allows lots of time for water to be reabsorbed back into the body. So almost every bit of water that this creature gets in its diet is reabsorbed back into its body, and that's an adaptation to living in desert conditions. So we're in the distal convoluted tubule now, and we get more reabsorption of calcium, sodium, and all the stuff that your body didn't really want to lose in the first place. Water will follow. We get some more reabsorption of water. We're talking about glucose, we're talking about water, ions, amino acids, all the things your body didn't want to lose in the first place. By this time your filtrate is basically urine, and it finds its way to the collecting duct. Now multiple kidney nephrons will lead to this collecting duct. Lots of nephrons feed into this one collecting duct, and this collecting duct dives down into that medulla, into that salty hypertonic medulla. And as you'd imagine, water will want to move from here into the surroundings. But the body's very clever. It can control how much water is reabsorbed here. And it does this using a hormone called anti-diuretic hormone. ADH released from the pituitary gland, and it acts on the kidney duct in the kidneys. What does ADH do? Well, if you remember, if you were to take a diuretic would make you go to the toilet lots. An antidiuretic does the opposite. So an antidiuretic increases the permeability of this collecting duct. It allows water to seep back into the kidney tissues, back into that medulla, back into those blood capillaries, and go back into your body. It doesn't let it take it back. It's saying, right, before this urine leaves my body, I'm taking this water back. So you get a low volume of concentrated urine. If you were to drink too much water, if you were to drink lots and lots and lots of fluid, you would stop producing antidiuretic hormone. Your collecting duct would become non-permeable to water. You'd get no reabsorption back into the body, and all of it would be dumped out of the collecting duct, down the ureter and into your bladder, and you'd be going to the toilet lots and lots and lots. So just to recap, antidiuretic hormone increases the permeability and allows reabsorption of water, whereas if you stop ADH production, it seals the collecting duct up, it stops water being reabsorbed by the body, and you would have a high volume of dilute urine. It's quite a lot to get your head around. It's a fairly complicated thing, but it's quite clever in the way it works. I hope that made some sense to you. Thank you very much for watching.